Thank you very much for choosing. So let's look at 6. What does 6 say? Okay, so we have f of x equals 1 over x squared, and they're giving us x equals 1, and they're giving us a delta x equals 0.5. And they want, again, part A, B, and C. Delta y, dy, and evaluate dy. Okay, good. So first of all, let's start with delta y. By definition, delta y is f of x plus delta x minus f of x. X is 1, delta x is 0.5. So then this will be f of 1.5 minus f of 1. Good. Then they want us to find, I'm going to calculate in a minute. So then they want us to find dy. Can anyone give us the definition of dy, the differential of y, please?
f1 of x times dx.
F prime of x times dx. Excellent. Good. So our function is x to negative 2. So we want to find f prime of x. Can anyone give us f prime of x now?
Negative 2x power negative 3.
Very good. Excellent. So then dy will be negative 2x to negative 3 times dx. They want us also to evaluate this. So then dy, of course, they're not telling us, but we know that these must be the same. So they also want us to evaluate negative 2. I'm not even going to write 1 to negative 3 because it's 1 multiplied by 0.5. And this is negative 1. Now, we want to evaluate this. So I'm going to put it in the graphing calculator and calculate. I meant to, okay. So we have 1 over 1.5 squared, and then minus 1. So this is negative 0.5555. Okay. So the actual error is this, triggered by an error of 0.5. So the actual error in the function is negative 0.55555 for the actual error of 0.5. In other words, from 1 to 1.5. From 1 to 1.5, this is the error. Now, according to the differential was negative 2 times 1 to negative 3 is still 1 times dx, which was 0.5, is this. So the difference between these two, for some, depending on the research or depending on the unit or the product, this is a difference of negative 0.5, 0.45, right? So you may say, well, but this is big. For this function, it appears to be, and for 1 to 1.5. So this is the actual, and this is the approximation obtained. Much easier to calculate, always. This is always easier to calculate, always, than this. Good. That's all we needed to do. Do we need another example, or we move on? No? This was something I just did with a student. This is another. Where is my book? I lost my book. Okay. I regained my book. Okay. Do we need to look at anything else from this set of 1 through 12?
I'd like to do another one.
Please.
Do
Anything.
number 8.
Yes. In number 8, we have f of x equals 2x minus 3. It's a very simple situation in which the derivative is just 2. But it's up to you. That's fine. So x equals 4, and we have delta x equals 0.5, which is also dx. Good. They're asking us to find delta y. By definition, this is f of x plus delta x minus f of x. X is 4, delta x is 0.5. So this is f of 4.5 minus f of 4. So in the calculator, I would have 2 times 4.5. I don't need a calculator for that. Okay. And then minus f of 4. 4 times 2 is 8. 8 minus 3 is 5. Okay, so it appears that the error, the exact error triggered by 0.5 error on x in this function is 1. Now we want to find the differential. And the formula for the differential one more time is, after we find f prime of x, which is 2, so dy equals f prime of x dx. So then dy equals 2 times dx, which is 0.5, and this is 1. There is absolutely no error at all in this case.
Thank you.
Thank you. Do we need another example, or we look at other things? Okay, I would like to look at something like this. As you see, the delta y is approximate. I don't like the way they present this, because there is an easier way that I just showed you, I think. But that's the starting point. Okay. So we want to approximate any of these numbers using the formula that we just looked at. What formula? This formula. Okay, so let's choose. Let's choose one. From 13, 14, 15, 16, 17, 18. Which one would you like to work on?
We do 17?
Yes. Let's look at 17. What does 17 say? Oh, I see. 17 is the cube root of 1005. Excellent. Big. Very good. Okay. So remember the concept. F of x plus a little bit of error is approximately f of x plus the error in y, dy, which we know the formula for, f prime of x dx. Here's what we need to identify. When we look at this expression, numerical expression, we have to be able to identify a function that we see here. We have to be able to identify x that we see here. We need to identify dx. And then everything else follows. I will differentiate, I will put dx here, and I will find f of x, and I'm done. But I need to identify these three things. And then, of course, be able to find f prime. So look here as intensely as you need. And first, come up with a function. What function do we see there? Although it's not explicit, but it's very clear. Which function do we see? If you just read it, you will know which function it is. Can anyone identify a function? that we see in this setup. Devin, what do you think? Okay. Jeremy, what do you think? Latisha, what do you think?
To be honest, I'm not 100% sure.
Well, just read it to yourself and you will figure it out. Just read. Yep, just read it. Is it natural log? Is it exponential? Is it absolute value of x?
Is the cube root?
Absolutely, exactly. There is nothing else. It's the cube root of x, which is the same with x to 1/3. Thank you very much. Which is 1/3, x to 1/3 minus 1, which is negative 2/3. Excellent. So we have the function, we have the derivative. Good. So we're done with that. Now look at this number and think in terms of the cube root and identify x and the small error. What do you think? What do you think x would be?
X 1,000?
Of course. What about the error? Remember, the error can be positive or negative. What is the error then? It's a silly question. Of course. Of course. So I have everything. I'm done. So the cube root of x, which is the cube root of 1,000, this is 10. The dx is 5. All I have to do is plug in 1,000 here and determine this number, and that's it. So let's see how much is f prime over 1,000. It's 1/3, the cube root of 1,000 squared. The cube root of 1,000 is 10. 10 times 10 is 100 times 3, 1/300. So I have everything. That's it. I just have to simplify it, but that's the whole thing. Once I identify the function, once second step, I identify the based on the cube root, of course, I would have chosen 1,000. A tiny error, so you cannot say 125 and the rest is error. No, no, no. The error has to be tiny by comparison to x. So this is 1,000. The error is positive because if this is 995, then the error is -5. And the x is 1,000. Okay, so it's positive. And I have the function, I differentiate, and I just plug in. So it's done. So from here, we jump over here with 10 plus 5/300, which is 10 plus, I simplify, 1/60, 600 plus 1, 601/60. I claim that the cube root of 1,005 is approximately 601/60. And you can say, show me. I will. So the cube root, no, I didn't mean that. Sorry, I meant 1,005 raised to the cube root, 1 divided by 3. And I want to determine 601 divided by 60. Look at that. Good. Very good pick. So again, what we did, we used a formula that says f of x plus a little bit of error equals f of x plus a little bit of error in y. We identify the function. Obviously, if you just read it, you don't have to do anything. It's the cube root, so the function must be the cube root. X to 1/3, we differentiate it. We figured out that x must be 1,000, and the minor error is 5. It's very minor by comparison to 1,000. We put in all these values. We calculate it. Don't approximate. You have to leave it as a fraction. And now we know that the cube root of 1,005 is very, very close to a 601/60. Good. See if we need another. And then we'll look at a word problem with the same thing, the same formula over and over again. Yes. And that's the end of 3.6. Do we need another example?
Can we do another one?
Yes, please. Any. Feel free.
Can we do 18?
Yes, let's do 18. Good. So 18 is the cube root. Oh, let's do something else. We already have done the cube root. What will be x in the cube root of 28? The cube root of what will be x and what will be delta x?
Was
24.
24, no, because the cube root of 24 is not an integer. But the cube root of much closer to 28.
What would be 25?
There is no cube root of 25. Much closer to 28.
$27.
Yes, 27, because the cube root of 27 is 3. And the minor error will be? If x is 27, the minor error is?
1.
One.
Exactly. Very good. So let's choose something else with a square root this time, because we know how to handle the cube root. Any preference? Let's do 14. So that's the square root of 8. I write the formula. F of x plus a little bit is approximately f of x plus f prime of x dx. Once we identify the function and we find its derivative and we find x and dx, we're done. It's just plug and chuck. But we need to identify these first. Can anyone give us the function? Please. Can anyone give us the function?
The square root.
Of course. Thank you very much. 1/2 the square root of x. Can anyone give us x? And then dx. Anyone, please? What do you think x and dx would be?
Would it be
Is X
4 and
8?
4?
Say it again.
Would it be 4 and 4?
So 4 and 4, remember, this is tiny. 4 and 4 cannot work.
No, I'm saying x would be 4 and then d of x would be 4.
But they have to be tiny by comparison. This has to be very small by comparison to x. When I say very small, I mean very small. It's an error. If the radius is 4 and I make an error of 4, I don't have anything. So coming back to this example, right? If I have 4 inches and the error is 4 inches, then I don't have anything. I can't. If the error again is if the radius should be 4 and the error is 4, then I don't have a disk. So the error has to be, by comparison, very small. So let's try again. It's a very good point. So remember, dx is a minor error. So what do you think? What can x be and dx? Remember, dx can be positive or negative. It doesn't have to be one or the other. It can be anything. So, what else do you think? Anybody, please? No ideas at all? What about 9 and -1? Is that okay?
Yes.
Okay. So, f of x, the square root of 9 is 3. F prime of x, the square root of 9 is 3. 3 times 2 is 6. 1 over 6. And dx is -1. That's it. So therefore, see the difference. So 9 and 1, the error has to be small by comparison to x. Good. So we have 3 minus 1 over 6. So this is 18 minus 1, 17 over 6. We claim that the square root of 8 is approximately 17 over 6. And I know you're going to say, show me. And you know I'm going to. So the square root of 8 and 17 over 6. You should always check. Who knows? You may have made an error somewhere. Pretty close. Good. Do we need anything else, or we move on to word problems? Do we understand how this works? Any questions? Okay, hearing none, you can always stop me. Finally, we're ready to continue our adventure into marginal cost, revenue, profit, and so on and so forth. So let's look at, because last time we could not work on problem 27. Now we can, because we have what we need. So 27 and 342. Okay. So we're given a function c of x, which is 0.002 x cubed plus 0.1 x squared plus 42x plus 300. And currently 40 units are produced per day. 40 units, whatever they are, it's not important. What is the current daily cost? So 40 per day, and the first question is, what is the current daily cost. What do I have to do?